Hey, welcome to my first academic paper video presentation. In this presentation, I'll be going over the paper, Hey, Preparing Humans to Do Tasks in Self-Adaptive Systems. We can see the authors of the paper listed below, and this paper was introduced in the 2021 International Symposium on Software Engineering for Adaptive and Self-Managing Systems, which was hosted in Madrid, Spain. The paper that I'm going to be discussing today is following 4 other papers that the same authors have written. The listed research has been done to narrow down and reason the need for human involvement in self-adaptive systems. The papers listed are in chronological order by date, and we can see the progression from taking the idea of human involvement in 2015 to discussing the trade-offs of involvement in 2017 to researching into the best ways of involving humans in 2020, and now trying to create a framework for preparatory notifications in 2021. All the following research has utilized resources on human behavior, attributes of human operators, and human-computer interaction to be able to discuss and create a framework for human interaction with self-adaptive systems. Currently with technology, we're limited in terms of the tasks, actions, or decisions that can be automated. Some decisions require a lot of analyzing and previous knowledge that may be difficult to acquire, and so they cannot be made into self-adaptive systems currently. Because of this, we require human involvement or input in these self-adaptive systems. This research paper gives the example of Amazon Scout robots. These robots are used to deliver goods in selected urban areas, and the delivery of vehicles is supported by a human operator who assists the system by generating delivery plans for the robots. The robot then goes and follows the plan while autonomously avoiding obstacles. Then it comes back for the human operator to set the new plan derived from updated information about deliveries that have come in that time. While the robot is out, the human operator is free to do any work, but needs to be ready to set a plan as soon as the robot comes back. You might be thinking, why is this a problem? Why is including humans in self-adaptive systems an issue? But research has shown that when humans are unexpectedly interrupted to perform a task without much attention, they not only work less efficiently, but also make more mistakes. This paper we're discussing today dives into researching the best way to use preparatory notifications in order to make the use of humans in self-adaptive systems the most efficient. Using preparatory notifications has to combat a lot of different problems that arise from interrupting humans. These things involved interference, context awareness of what the operator has to do, just general human nature, and the urgency of the task at hand. So the main idea of this research is to provide a formal framework for designing self-adaptive systems where a preparatory notification can be used as a tactic to proactively aid the human operator in improving the overall system utility. They also evaluate this method by using probabilistic model checking to analyze when and in what forms to use the preparatory tactic as an adaptation strategy. On the right, we see a figure which shows the timeline of how this system works. So we send the preparatory notification a certain amount of time in advance before that task needs to actually be done. This time is called the lead time, and the research goes into looking into what an optimal lead time is for different types of tasks and what to show in that notification to capture the attention of the user. So with the use of this framework, preparatory notifications can give context and make the user aware of when they need to complete a task. The framework that they have created considers many different attributes, which allows it to be utilized in many different self-adaptive systems. So they're taking into account the different training levels, the impact of the operator's attention, and the complexity of the task that needs to be completed. To evaluate the framework, they modeled a human and robot interaction for a delivery service using Prism games. Prism Games is a tool used for verification of probabilistic systems that can incorporate competitive or collaborative behavior modeled as games. The model was created to be able to create a strategy that maximizes the expected system utility by selecting when notifications should be given and in what form. The experiment was run with different operator levels, and a lot of emphasis was put on task complexity versus lead time. The evaluation found that the optimal lead time generally increases with the increasing context complexity, but the longer lead time doesn't always bring better results, and it could actually weaken the system utility. This was due to the cost of waiting after the operator has been able to understand the task by employing only a fraction of lead time, while the rest time is just wasted. So the researchers presented a general framework based on probabilistic model checking to determine when and in what forms a notification should be used as an adaptation tactic to attract human attention and allow them to comprehend the context of a problem when they have to complete an operation. One limitation of our evaluation is the research did not directly correlate the analytical results with actual systems through an empirical study, but rather the findings were supported by other research which incorporated empirical studies. Another limitation was that a lack of direct procedure for obtaining the task priority and the process of shifting the attention of the operator. These topics that I've discussed were identified by the researchers, and they were identified as potential future research factors. That's all. Thank you for watching.